Hi, everybody. Welcome back to TGCS. My name is Tim Gallagher, and today we're going to be discussing AP Computer Science A, topic 4.5, implementing array algorithms. And in this third of our three videos, we'll develop code for our standard and original algorithms that involve arrays and determine the results of these algorithms. Specifically, we're going to focus on these three algorithms. First, determine if all elements in an array have a particular property. Next, shift or rotate elements to the left or right in an array. And finally, reverse the order of the elements in an array. All right, before we get started, let's talk about what our algorithms need to do, what our constraints might be, what are the results going to be produced, and some questions we might want to answer before we get started, such as what's our goal? Do we need to get a value or a location or a calculation? What type of result do we want? What type of values are in the array? Are they objects or primitive types? How can we compare, accumulate, or check an attribute of these contents? And finally, do we always need to traverse the entire array with our algorithm? Might there be some conditions where we can halt our algorithm before traversing the entire data structure? All right, let's look at our first algorithm. So this first method, we want to determine if all of the strings in the array words are longer than the parameter length. And this method will return true if they are all longer than length. Otherwise, it'll return false. So let's discuss the algorithm first. What are the steps that we're going to take to evaluate these strings and return a Boolean? Well, we're going to need to traverse an array. And we'll need to compare the length of each element in the array to the parameter length. But what are we looking for? Well, if the string is longer than the length, we want to keep going and evaluate the other strings. There's nothing to do if we haven't found one yet that does not meet our criteria. However, if the string is not longer than length, that's the problem that we're going to have to deal with. All it takes is one string to make the all words longer than no longer true. So we should immediately return false. We don't even have to check the rest of the strings. Even if the rest of the strings are long enough, we already found one that isn't. So there's no way that this method can return true. If we traverse the entire array without returning false, well, that means all of our strings are longer than length and we can return true. So that's our algorithm. Can we turn this into code? Feel free to pause here if you want and take a crack at this implementation. Okay, let's do this together. To start, let's take our algorithm and turn it into our Java comments. So this will help us, again, direct how we can write our code. So we know we need to traverse the array. I'm going to use a enhanced for loop here because we don't need the index numbers. So for each string current within words. Now, I want to first check to make sure that current isn't null because there might be some null values in this array. This wasn't like the other example where we used an initializer list and we knew there was no null values. We don't want to try to call the length method on a null string. So we just won't consider null values in our algorithm. Now, there are a few ways that we can check to see when current.length is not greater than the length parameter. But here, what I just did was I used a greater than symbol and then I put a not symbol with the exclamation point outside of my Boolean expression. If I found a word that is not null and is not longer than the length, well, then I'm immediately going to return false. And then finally, if I get through the entire loop, well, that indicates that I never found a word that wasn't long enough. So now we can return true. And that's our algorithm. So we checked if all the elements of an array had a specific property. And in this case, we verified that all of our strings were at least a certain length. And if that was true, we returned true. If we found one that didn't, we immediately returned false. All right, let's try another algorithm. With this method, shift left, we want to shift all the values within an array one position to the left. And while doing so, we want to take the original leftmost value or the first value in the array and transfer it to the end or the rightmost position of the array. All right, let's discuss this algorithm. So we know we want to temporarily save the first element, the element in the first position, because we know we're going to need it at the end to put it at the end of our array. So let's traverse the array. And then we're going to assign the value that is one position after our current location to the current position in our array. And this is what will shift each element one position to the left. After we're done with the loop and the traversal, we'll put the original first element in the last position. And that's it. Pause if you'd like to give this code a shot, and we'll be back in just a moment. Okay, here we go. Let's turn these algorithm statements into comments. And now let's write the code for our algorithm. So temporarily store the original first element. I'm going to need a local variable. We'll call it temp. And we'll store the element from the first position in our array into this temporary variable. We're going to traverse the array using a for loop. Now notice that our Boolean condition is less than length minus 1 because we know that we want to prevent going out of bounds like we saw in the last video when we're accessing consecutive elements here. Now our assignment statement takes the value that is one position to the right of our current value, I plus 1, and assigns it into the current position that we're visiting. Now, using the I plus 1, that's the reason why we had to include a minus 1 in our for loops Boolean expression. So we take every value that is after our current values bracket I value and put it into values bracket I. Finally, after the loop is done, we put our original first element that we stored in temp into the last position in the array that we've been shifting. And that does it. This will shift all the elements one position to the left and put the original first element in the last position. All right, let's look at one more algorithm. For our last algorithm, we want to reverse the elements of an array. Let's look at how we might do that. So here's an array, and there's a few different ways we could do this, but let's do this within the context of one array. We're not going to create a brand new array and copy them over. Let's consider this is the array of integers we want to reverse. First, if we swap the value at index 0 with the value at index length minus 1, the 12 and the 22 are switched, right? And then we want to swap the values at index 1 and index length minus 2, so 42 and 8 get switched. Then we'll swap the values at index 2 with the value at index length minus 3, so the 38 and 17 have switched. And 92 is in the middle, so it doesn't need to get switched at all. And that's it. Now our array has been reversed. So I want to point out a couple of things here. You'll notice that index 0 swapped with index length minus 1, 1 swiped with length minus 2, and the element at index 2 swapped with the element at index length minus 3. So index I always swapped with index length minus I plus 1. And we can use this pattern to swap pairs of elements as we traverse through each element of the array. Also, notice that we only have to loop halfway through the entire array to swap out all the elements in the array. This means our iteration will only need to go to the length of the array divided by 2. All right, pause here if you want to have a go at our last algorithm. Okay, let's put down our comments and complete the code. So, not a lot of comments here. The algorithm is short, but it is complex. So let's start by using a for loop. We're going to traverse through the array, but notice we're only looping through the first half of the array by using our length divided by 2 in our Boolean condition. Note that this works regardless if there are an even or an odd number of elements in the array. It doesn't matter. All right, now let's swap 2 elements within our loop. So how are we going to do this? Well, first, I'm going to need a temporary variable to store the original value in position I. Then I'll need to assign the value from length minus I plus 1 to the position I in my values array. And then finally, to complete the swap, I'll need to assign temp to the position values.length minus I plus 1. And that completes the swap of moving one element from one position to another position and vice versa. After doing that all the way through, continuing with our loop, we will have traversed the first half of the array and swapped all of the corresponding elements in the second half of the array. So our algorithm's complete and we reversed an entire array. All right, so today we developed code for standard and original algorithms for arrays and determined the result of those algorithms. Specifically, we looked at determining if all elements of an array had a specific property. We shifted the elements of an array to the left, and we reversed the order of the elements in an array. All right, that's it for this video. Thanks so much for joining us. Don't forget to hit that like button. Please subscribe to my channel, and we'll see you next time. Take care.